In this lesson, we will be working on factoring quadratic expressions. We will be looking for what we multiply together to get the expression which is the product. So, if you recall, when we do factoring, what we are looking for first is to find the common monomial factor, which means is there a term that they all have in common? We'll divide that out first. Then we take a look to see if what we have left is a special pattern, such as the difference of squares or a perfect square trinomial. And then we'll finish factoring by using the method of your choice, which might be the AC method or usually trial and error. At the end, we want to make sure we always factor completely. So let's do some examples. In our first section, we have the pattern of factoring x squared plus bx plus c, where our leading coefficient is 1. So when we take a look at these examples, we'll notice that we do not have a common monomial factor other than 1. So, taking a look, we can't factor out anything other than 1, so we're going to set up our two sets of parentheses, and this is the best choice for when we have our leading coefficient of 1. We decide what would we multiply together to get x squared, which would be x times x. Then we decide what would I multiply together to get negative 48, but when I add it together, I get negative 2x. So thinking of those factor pairs, I would have 6 and 8, and when I add them together, I need to get a negative 2, so I'm going to use a negative 8 and a positive 6. So it isn't required, but you may want to check. We do already know that the first times the first is going to give us our x squared, and the last term in each 6 times negative 8 is going to give us negative 48. But if you would like to quickly check your outside and your inside terms to be sure that you're getting this second term in your quadratic expression, x times negative 8 is negative 8x, and 6 times x is 6x, and when I add those two together, I do get negative 2x. So that can be my check simply by multiplying the outside and the inside terms together. Let's take a look at our next example. We have x squared minus 6x plus 9. Since our leading coefficient is 1, we know that x times x gives us x squared. So again, we're looking for factor pairs that will multiply together to give us a positive 9, but when I add them together, I'm going to get a negative 6. So that's going to mean that we would want to use a negative 3 and a negative 3. We can check by multiplying the outside and the inside, each giving us negative 3x, that when added together give us negative 6x. You can also write these factors as x minus 3 the quantity squared. In our next example, we have x squared plus 8x plus 16. Again, our leading coefficient is 1. So to find our factors, we know that we multiply x times x to give us x squared. And then we find what two numbers can I multiply together that give me 16, but when I add them together, I get a positive 8. So that would be a plus 4 and a plus 4. When I multiply the outside terms, I get 4x, and the inside terms I get 4x. When combined gives me 8x. And I could also write these factors as x plus 4, the quantity squared. In our next example, we have x squared plus 6x minus 2. So I can multiply x times x. And then I think to myself, what two numbers can I multiply together that will give me negative 2? But when I add them together, I'll get 6x. There aren't two numbers that I can multiply together that give me negative 2 that have a sum of 6. So this one is not factorable. Let's move on to the next pattern. This pattern now has a leading coefficient, and it's of the pattern ax squared plus bx plus c. Our leading coefficient will be other than 1. So our first job is to look at all three of the terms and see if they have a common monomial factor. In other words, can something be divided evenly into all three? 4, negative 4, and negative 3. And that would be no. So we're going to draw our parentheses, and I'm going to use trial and error. So I say to myself, what could I multiply together that gives me 4y squared? So I'm going to try 2y and 2y. Then I say, what can I multiply together that gives me a negative 3? So that would be 3 and 1. And then I would need to decide what signs would need to go and if this is going to work. I can again do that by saying I'm going to multiply the outside and the inside terms together. So I'd have 2y and I'd have a 6y. Could I use those two in any combination to get negative 4y? If I make the 6y negative and I take 2y minus 6y, that will give me a negative 4y. So this is where my negative sign needs to go in order to multiply the negative 3 times the 2y to get negative 6y, and then 2y times 1 would give me 2y. In the next example, I check to be sure that there is not a common monomial factor. 10, negative 3, and negative 1 can only be divided by 1. So we'll set up our two parentheses. And trial and error, I could use 10 and 1 or 5x and 2x as my factors. So I'm going to use 5x and 2x as my first trial. And then I want to decide what can I multiply together that's going to give me 1. So I need 1 times 1, and I obviously need one of them to be positive and one of them to be negative. So I'm going to multiply together 5x times 1 and 2x times 1. So I have a 5x and a 2x. I want to be able to combine like terms to get negative 3x. That would mean that my 5x needs to be negative, my 2x needs to be positive. So I'll put my plus sign here to make my 2x positive, and the negative sign by the second one to make my first product negative, which will give me negative 3x. Let's take a look at the next example. We have 2x squared plus 7x plus 1. So I know that I would multiply 2x times 1x to get 2x squared. And then I would multiply 1 times 1 to get a product of 1. So when I check my outside and my inside terms, I have a 2x and I have an x. I can't use those in any combination to get my 7x, my middle term. So this one is not factorable. In the next example, I have 9x squared minus 12x plus 4. I look for the greatest common or the greatest common monomial factor. They don't have anything in common. So what can I multiply together that's going to give me 9x squared? Could be 9x and 1x or 3x and 3x. I'm going to try 3x and 3x. And then what can I multiply together that's going to give me 4? I could do 4 and 1 or 2 and 2. I'm going to try 2 and 2. And since my final product is a positive 4, but my middle term needs to be a negative, I would know that both of these 2's need to be negative. So let's check. 3x times negative 2 is negative 6x, and negative 2 times 3x is negative 6x, which when combined together gives me negative 12x. I could also write my factors as 3x minus 2, the quantity squared. In our next example, we are going to be factoring special patterns. The first special pattern that we'll be looking at is called the difference of squares, and that is because you'll notice that there is a subtraction sign. You'll notice that the pattern is a binomial. It has only 2 terms, and you'll also notice that both of the terms are perfect squares. So we first take a look to see if 121 and 16 have common factors. Since they don't, we'll draw our 2 sets of parentheses, and what we want to do is to take the square root, or what do I multiply times itself, to give me 121x squared. That's going to be 11x and 11x. I do the same thing with the last term, 16. I take the square root, or in other words, what do I multiply times itself that gives me 16. And in order to get the difference, the minus sign, one of our factors needs to be positive and one of them needs to be negative. When you check the outside and the inside terms, they will be the same, but opposite, so when we add them together, we'll have a sum of 0. So we have negative 44x and positive 44x gives us 0. X squared minus 25. We know that x times x gives us x squared, and we're looking for the square root of 25, or what do I multiply times itself, which would be 5, one of them being positive and one of them being negative. In this difference of squares pattern, we're looking for what do we multiply times itself that gives us 4x squared, or the square root of 4x squared would be 2x and 2x, and the square root of 9 is 3, or what do we multiply times itself that gives us 9. And again, with the difference of squares pattern, one of them must be positive and one must be negative. X squared minus 9, we have x times x and 3 times 3, and one of them must be positive and one of them negative for the inner terms to have a sum of 0. Let's take a look at our next example. We have 14x squared plus 2x minus 12. When we are factoring, the first thing we want to do is to take a look and find our common monomial factor. In this case, we can divide all three of the terms by 2. So we're going to take that out first and divide them all by 2. Seven x squared plus x minus 6. Now, we need to factor completely, so we'll leave our common monomial factor of 2, and then we'll go from there. What can I multiply together that gives me 7x squared? Well, that would be 7x and x. Then, what can I multiply together that's going to give me 6? I could either use 3 and 2 or 6 and 1. Well, if I use a 3 or a 2, and one of those is in the second position, and I'm going to multiply either one of those times 7, that's going to give me a rather large number, and I do know that my middle term needs to be a positive 1. So that really isn't going to work out. And we need to be able to think ahead and to look at this ahead of time so that we don't need to make too many changes. So let's try 6 and 1. Well, if I put the 6 over here in this position, it would be 7 times 6 is 42. That's quite a ways away from 1x. So when we multiply, I'm going to put my 6 here, 6 times 1. So checking, I have 7x as my outside terms if I multiply those two together. And 6 times x gives me 6x. So deciding what combination of positive and negative would result then in my middle term being a positive 1x. So that would give me positive 7x and negative 6x to give me my final factors. Let's take a look at the next example. We look for the common monomial factor. Both of these terms can be divided by 3v. So when I divide, I get v minus 6, and then I'm finished. There isn't anything else I can factor from v minus 6. Let's take a look at the next example. 12x squared plus 3x plus 3. I can divide all three terms by 3. So that gives me 4x squared plus x plus 1. Now, if I want to continue factoring, I would decide what can I multiply together to give me 4x squared. Well, I could do 4x and 1x, and 1 and 1, and all of my terms are positive. So when I check with my 4x times 1 and my 1x times 1, that's going to give me 5x, and I want my middle term to be a positive 1x. So would it make a difference if I changed my 4x squared to have factors of 2x and 2x instead of 4x and 1x? It still is going to be plus 1 for each of them for the last term. So now I have a 2x and a 2x if I do my outside and my inside terms, and when I add those together I get 4x, but I want my middle term to have a sum of 1x. So in this case, when I am factoring this quadratic, the only thing that I can do is to divide by the common monomial factor, and that's it. Let's take a look at the last example on this page, 4u squared minus 36. They have a 4 in common, so I'm going to divide them both by 4, which gives me u squared minus 9. And I need to continue factoring, and I do recognize that u squared minus 9 is a special pattern called the difference of squares. So u times u is u squared, 3 times 3 is 9, and one of them must be positive and one negative to give me the difference of squares. Let's take a look at just a couple of more examples. So 6y squared minus 225. That's a special pattern called the difference of squares. So 16 and 225, if we take a look, neither of those have a common monomial factor. So we'll draw our two sets of parentheses. We have 4y and 4y, and 15 and 15. Sorry about that. 15 and 15. One of them is positive and one negative to give us our difference of squares. In the next example, we have 4z squared minus 12z plus 9. We look for the common monomial factor, and there isn't one. Now this is a special pattern called the perfect square trinomial. The reason it's called that is because it is a trinomial, which means it has 3 terms, and the first term and the last term are perfect squares. So let's take a look at this special pattern. The way to factor this is that I want to take the square root of the first term, or in other words, what do I multiply together? I have 2z and 2z. And what would I multiply together or take the square root to get 9 would be 3 and 3. And then I look at the sign of my middle term, which is minus, and my ending term is positive, so I would need 2 negatives to get those final products. Let me check by doing my outside and my inside. I have negative 6z and negative 6z, which gives me a negative 12z, which is my middle term. And notice when you have a perfect square trinomial that your factors, your binomials, are the same, so can be written as 2z minus 3, the quantity squared. So this also looks like a perfect square trinomial because 36w squared is a perfect square and 25 is a perfect square. So if you want to take a shortcut, all we need to do is say what is the square root of 36w squared? It's 6w. And what is the square root of 25, which is 5? And what is the sign of my middle term? It is positive, and that factor will be squared. Now if you wanted to check, you could simply write it out twice, and again checking only the inside and the outside terms. So we have 6w times 5 and 6w times 5, and that would be 30w and 30w. And if we combine those like terms, we get 60w. To review, where we are factoring quadratic functions, be sure to check for the common monomial factor, then look to see if there is a special pattern, and finally finish factoring completely. Please complete the reflection.